So we've talking about percent concentration again. In our first video, we determined how to calculate percent concentration. Remember, we put our units of solute over our units of solution and multiplied by 100, and that's how we got our percent. We also talked about the definition of what percent concentration means. And percent concentration is basically our units of solute per 100 units of solution. Okay? And our units, which units we use, depend upon which percent concentration we've got. So if we've got mass over here, it's going to be grams. If we've got milliliters over here, or volume over here, it's going to be milliliters. So mass to volume is grams of solute over 100 milliliters of solution. Mass to mass is grams of solute over 100 grams of solution. And volume to volume is milliliters of solute over 100 milliliters of solution. So all of these right here should look familiar. It's something over something else. So that's actually a conversion factor. So we can use these just like we did all the conversion factors in Chapter 1. So we're going to use some strategies to solve some of these problems. The first one is we're going to change, remember that delta sign is change the concentration to units we can cancel out. So whenever I see a concentration, I'm going to change it to this form over here. Okay. Then we're generally going to start with a thing that's not the conversion factor in our problem. Okay. That gives us a couple of things that we can do to start out our problems. So let's go ahead and look at some of these problems. This problem reads, how many grams of sodium chloride, so the question is how many grams of sodium chloride are needed to prepare 150 milliliters of this solution. So this is milliliters of solution. Now the solution happens to be 0.900% mass to volume. Okay, so I've pulled out all the information I can out there. Now I can start the problem. Remember, the first thing I'm going to do is change that to a form that I can actually use. This is 9.900 grams of solute over 100 volume, so it's milliliters of solution. And our sodium chloride is our solute. So that's what we're looking for. So we're going to got a conversion factor and we've got a number. So we're going to start with a thing that's not the conversion factor. So we've got 150 milliliters of solution. We're going to use our conversion factors to then get how much solute. If milliliters of solution is in the top, where does it have to be to cancel out? Well, it has to be in the bottom. So we're going to put our milliliters of solution from our conversion factor down in the bottom. The thing on the other side of the line goes on the other side of the line. Now milliliters of solution cancels out with milliliters of solution. Do keep in mind, milliliters of solution does not cancel out with milliliters of solute. Okay? Two different things. That's why I'm leaving all my labels in there so I know what can cancel out and what can't cancel out. Now the only units we didn't cancel out are grams of solute, which in this case we know is our sodium chloride. So that's how much sodium chloride we want. Is that what it's asking for? How many grams of sodium chloride? Yes, it is. So then we can go ahead and type this into our calculator. And we get an answer of 1.35 grams of sodium chloride. So we've answered our question. Let's try another one. Here we have two separate questions. The first question reads, how many grams, so again, how many grams of our KBr, and our KBr is our solute. It's asking for how much solute do you have to add to make this many grams of that solution. So this is the grams of solution. 25 0.0 grams of solution. Now the solution happens to have a concentration of 15% weight to weight. Okay. So the first thing I'm going to do, get that percentage out into things that we can use to cancel out. So this is 15 grams of solute over 100 grams of solution. Okay. Now we can start analyzing the information. We're going to start with the thing that's not the conversion factor. 25.0 grams of solution. Solution's on the top, so where do grams of solution have to be to cancel out? Well, it has to be on the bottom. So we're going to take this conversion factor and we're going to put the grams of solution on the bottom. The grams of solute go on top. Grams of solution cancels out. The only thing we have left are grams of solute, and in this case it's the KBR, and that is exactly what we were looking for. So we can go ahead and do this calculation. 25 times 15 divided by 100 equals 3.75 grams of KBR. Okay. Now we're going to go ahead and do another problem. This time we're going to look for something a little different. It asks for how many grams of a 9.5 solution. So here we want the grams of solution. Now the solution happens to be 9.5%, and it asks, can we make with 3.75 grams of KBR. Our KBRs are solute. Okay. So we're going to change this concentration into numbers we can work with. 9.5 grams of solute to 100 grams of solution. We're going to start with the thing that's not the concentration unit, or not the conversion factor. So we're going to start off with our 3.75 grams of our solute. Now in this case, solute's on the top, so where does it have to be to cancel out? Well, it has to be in the bottom. So if solute has to be on the bottom, we have to flip this over. It's 9.5 grams of solute. The thing on the other side of the line goes on the other side of the line. Now our grams of solute cancels out with grams of solute. The only thing we left is grams of solution. And that is what we're looking for. So we'll go ahead and type that into the calculator. 3.75 times 100 divided by 9.5. And we get 39 grams of solution. So we had two questions that we were able to figure out what the answers were by following the same type of methodology. Now we're going to do another set of questions, and this is known as a dilution problem. Sometimes it helps to draw a picture out, so I've drawn a little bit picture here so that we can figure out what we're talking about when we read this information. So it asks how many grams of water. So this is what we're asking for right there, grams of water. Do you have to add to a solution that has 25.0 grams, so that's the grams of solution. The solution happens to have a concentration of 15% weight to weight. And when we add the water, we're going to prepare a solution that is now 9.5% weight to weight. Okay. So we've got two things going on here. We've got a solution over here and a solution over here. The one thing that's the same in both is the amount of solute. So the amount of solute here equals the amount of solute here. All we've done is add more water, right? So if we can find the amount of solute here, then we know the amount of solute that's going to be over there. So in order to do any calculation, we need two numbers. So we're going to start with a solution that has two numbers associated with it. We're going to use those numbers to calculate how much solute is in there. And that amount of solute is going to be the amount of the second number that we're going to use with this concentration. Okay. So the first thing I'm going to do here is change these into conversion factors. Solute over 100 grams of solution. And this is 9.5 grams of solute per 100 grams of solution. All right, so first point, we're going to do two problems here to answer this one question, is to find out how much solute is in this solution. So we're going to start off with the thing that's not the conversion factor. That's the 25. 25.0 grams of solution. This goes with this concentration, so that's the conversion factor we're going to use here. We have solution in the top, so solution has to be in the bottom in order to cancel out. And 15 grams of solute on the top. Grams of solution cancels out, and we get 3.75 grams of solute. Okay. That's the solute that is in this one over here. But we know that's the same amount of solute that's over here. So now we can say that this has 3.75 grams of solute. Okay, now we have two numbers for our second solution, and we can do a calculation with that one. So our second calculation is going to use these two numbers. We have 3.75 grams of solute, because we start off with the one that's not a conversion factor. We're going to use our conversion factor here. Solute's in the top, so we need solute in the bottom. 9.5 grams of solute per 100 grams of solution. Grams of solute cancels out. We get 39 grams of solution. And so this is how many grams of solution we've got in the second case here. So we had 25 grams, we add some water, and now we end up with 39 grams of solution. Now, is that what the problem asked us for? Let's go back. It asked us for how many grams of water were added. So we have one more thing we've got to do. Remember, our amount of solvent that we add, that's our water, is going to equal the final amount here minus the amount that we started with. So we're going to end up with 14 grams of water. So we started off with 25 grams, we added 14 grams, we added our 14 grams, and we end up with 39 grams of water. Now I want you to look at your notes. Hopefully you've been taking notes on these two. And notice that we did the problem over here and we asked two separate problems. How much solute was in the first one? Then we used that amount of solute and asked how much solution is in the second one. Those two problems that we asked separately were the same process that we did here to answer this one dilution problem. So every dilution problem is made up of two separate problems. The key for dilution problems is to pull out the information. One of your solutions you're going to have two numbers for, one solution you're going to have one number for. Make sure you get the numbers in the right solution and then start with the one you have two numbers for. Okay? So we're going to be doing more of these dilution problems as for practice.